Okay, so 4-6 is all about congruence in right triangles. So this theorem, HL right here, can only be used in right triangles. So if you don't have a right triangle, you cannot use HL. So please keep that in mind. So what this says is if two right triangles have one pair of congruent legs and congruent hypotenuses, then the two triangles are congruent. So a key thing to know here is in a right triangle, we always have a right angle. The legs are the sides that are touching the angle, and the hypotenuse is always the side across from the right angle. You will need to know this for the rest of geometry. We will use this over and over again, that the hypotenuse is across from the right angle. So when I ask you in class, where's the hypotenuse at? Well, it's across from the right angle. So please keep that in mind. It's right there. So I made a checklist. That way you guys can always be sure you're using HL appropriately. Okay. First of all, two right triangles. They have to be right triangles. They have to have a right angle. If there's no right angle, you can't use HL. The triangles must have congruent hypotenuses. So the side across from the right angle, those have to be congruent no matter what. Okay. And then there's one pair of congruent legs. Okay, so these legs right here, it could be this leg and this leg, or this leg and this leg. The point is that they are congruent, okay? So if they have a pair of congruent legs, congruent hypotenuses, and it's a right triangle, then this works, okay? Notice if they did have just two congruent legs, so let me draw out a short picture right here. If we had congruent legs, this would just be angle, side, angle. Angle, side, I said that backwards, I'm sorry. Side, angle, side, angle, side, because this angle is in between these two sides. So just because you see a right angle doesn't always mean it's going to be HL. This isn't HL because the hypotenuses aren't congruent. So HL is just another way to prove right triangles congruent. It doesn't prove all triangles congruent because not all triangles have hypotenuses. Only right triangles do. So it's called hypotenuse leg because it has to have a hypotenuse, which means it has to be a right triangle. So please keep that in mind. Also recognize sometimes we'll use these other ones. And the more appropriate name for shared side is reflexive property. So I already had changed that, but didn't change it on my old notes. So the reflexive property, we might use that, such as in the textbook right here. This uses the reflexive property. They have congruent hypotenuses, the sides across from the right angles. Okay, remember if we have a right angle here, we have a right angle here. And then this shared side, using the reflexive property, this shared side is actually also a congruent leg. So we have hypotenuse, leg, and it's a right triangle. All three conditions are met. We would want to do that with our little checklist here. Okay, right triangles. Triangles have congruent hypotenuses. There's one pair of congruent legs based off the reflexive property. Just like the other ones, for these ones that say proof on here, remember your congruent statement is triangle blank, congruent to triangle blank with what? Remember, it might not always be HL. It might be side, 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 angle, side, angle, side, angle, 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 side. And with what? Sometimes you might use midpoint bisector, isosceles triangles. Look back at 4-5 to learn what we learned about isosceles triangles. Or the reflexive property, just like we used in that last one. So keep that in mind. Math Excel is also an option here. It just you select all of these things in drop-down menus. And that's what 4-6 congruence in right triangles is all about.